Today we're going to be working on Unit 2, Lesson 8, Applying Similarity to Solid Figures. So we have two vocabulary words. Our first vocabulary word is similar solids. Our second one is congruent solids. We're going to start off with a theorem. So theorem are ideas in mathematics to help us solve out problems. They have been proven. So if two polynomials are similar, then their areas are proportional to the square of the scale factor between them. Scale factor is represented by the letter K. So if ABCD, this means is similar to FGHJ, then the area of FGHJ divided by the area of ABCD is equal to one of the sides divided by the other side squared. So that's creating our scale factor. So let's take a look at the first one. It says, use similar figures to find the area. So we have rectangle ABCD and rectangle JKLM are similar rectangles. Find the area of rectangle JKLM. So I'm going to start off with creating my ratio from the scale factor that I have. So I have the area of JKLM divided by the area of A, B, C, D equals. Now we need to pull a side from both of these. They need to be the same side with respect to their figure. So if we look, JM, and we also have AD. So JM over AD, and this is going to be squared. So I pulled that from the theorem. Now I'm going to fill in the information that I have. So I have the area of ABCD, I have the side length JM, and I have the side length AD. I don't have the area of JKLM. That's what I'm trying to solve for. So area of JKLM divided by the area of ABCD is 32. It's given in the figure. So this is 32 equals the length JM is equal to 5. And the length AD is equal to 8. And we're going to square both of those. So that means the area of JKLM divided by the area of ABCD, which is 32, equals 5 times 5 is 25. 8 times 8 is 64. Now to solve for the area of JKLM, I'm going to multiply both sides by 32 times 32 times 32. So I get the area of JKLM is, multiply that out, we get 12.5 centimeters squared. So again, I multiply 25 times 32, divide by 64, and I get 12.5. So for number one, we're finding the area. For number two, we're going to want to find the scale factor. So I'm going to start off with creating, again, my ratio, the area of LMNP, divided by the area of ABCD equals, and this is going to be our scale factor, which is K. So plug in what we have. So we have the areas of both of these. This is going to be 50 divided by 72 equals K squared. I notice that I have some commonality between the 50 and the 72. So I'm going to divide out a 2 from both of those. And that's going to leave me with 25 over 36 equals K squared. Now I'm going to take the square root of both of those so I can get rid of that square. So that gives me 5 over 6 equals K. So what do we have? We have that LM over AB is my scale factor. We've solved for my scale factor. We know my scale factor is 5 over 6. So we don't know what LM is. That's our x. We know AB is 6. And we know our scale factor is 5, 6. So if we look at this, to make these equal, x has to equal 5. Or if I multiply both sides by 6, I get x equals 5. So my length that I was missing is 5. We have another theorem, theorem 6.2. It says if two similar solids have a scale factor of a to b, then the surface area has a ratio of a squared to b squared, and the volume has a ratio of a cubed to b cubed. So we're going to use that idea to solve out number 3. So it says use similar solids to find the volume. The 3 cones are similar. Find the volume of each cone. So if I take a look at the first cone, I have my radius of 5. I don't have my height, so I'm going to have to use Pythagorean's theorem. A squared plus b squared equals c squared. So that's going to be 5 squared plus h squared, because that's what we're solving for, is our height, equals 12 squared. So we have 25 plus h squared equals 144. Unfortunately, with this one, we're not going to get out a very nice number. Subtract 25 from both sides. We get h squared equals 119. So we don't always get out nice numbers like we were before. Take the square root, take the square root. H equals, so we're going to just leave this as the square root of 119. I'm going to plug that into the formula. So cone 1 is volume equals 1/3 the area of the top of it times the height. So this is going to give me 1/3 times pi times 5 squared, and my height is the square root of 119. So this looks kind of messy. We can clean this up a little bit. 5 squared is 25 times pi times the square root of 119. All that divides by 3. Now we want to find cone 2. So we're going to have to do a little bit of work to find cone 2. And we know that cone 2 is similar to cone 1. The scale factor for cone 2 to cone 1 is 5 to 6. 5 to 6. That's where we got it from the ratios, or from the radiuses. So find the volume of cone 2. So the volume of cone 1, divide by the volume of cone 2 equals that ratio that we came up with. 5, because the 5 is connected to cone 1, over 6, because that's connected to cone 2. We're dealing with volume, so we're going to cube this. But I don't want cone 1. I want to solve for cone 2. So to do that, I'm going to need to multiply both sides by cone 2 and then divide this out. So it'll give me volume of cone 2. Again, I'm going to multiply both sides by cone 2, then divide this out. So this gives me 6 over 5 cubed times volume of cone 1. Well, we know the volume of cone 1, 6 over 5 cubed. Cone 1's volume is right here, 25 times pi times the square root of 119 divided by 3. So what we want to do now is we want to cube those. So 6 cubed is 216. 216. 5 cubed is 125. And we're going to multiply that times 25 times pi times the square root of 119 divided by 3. And when we multiply those two together, we end up getting 72 times pi times the square root of 119 over, sorry, not 25, 5. So volume of cone 2 is right here. Volume of cone 1 is right here. Now we want to come up with volume of cone 3. Well, look at this. Cone 3 is the same as cone 1. They're similar shapes, 5 to 5 or 1 to 1 ratio. So that means cone 3 is going to be 25 times pi times the square root of 119 over 3. So that's the volume of cone 3. So again, I started with cone 1. I had to find Pythagorean's theorem to find the height. Cone 2, I set up my ratios. I solved for the volume of cone 2. I had to do a little manipulation of my formula. Once I had that, then I just plugged in the information that I had, and then I multiplied them out. 216 times 25 divided by 125 times 3. I just kind of left these to the side because I didn't want to get it too messy. And that gave me 72 over 5. For cone 3, we notice that they are both, cone 1 and cone 3 are 1 to 1. So it just was a repeat of what we had for cone 1.